Students, good afternoon. Good afternoon to all. Good afternoon, Vaishnavi. Good afternoon, Sakshi. Good afternoon, Gaurav. So, students, can you able to hear my voice? Am I audible and visible? Yeah. Good afternoon. Good afternoon, students. Good afternoon. Fine. So, all of you can able to hear my voice, right? Can you all able to see the screen? Yes. Okay, Gaurav. Good, good. Great. So, let's continue. Yes. So thank you so much for your response, students. So let's continue with the electrochemistry. So on Friday, in the last session, we have discussed something related to conductivity cell, etc. Right? Let us recap those parts today, and then we will move on to the next topic, today's topic. Okay. So we have studied what is cell conductance, and mostly we have discussed some formulas in last class, no? So what is the formula for cell conductance? Actually, conductance is denoted by the letter G, right? So conductance is nothing but the reciprocal of resistance. So G is equal to, or cell conductance is equal to 1 by resistance. Okay. And also I gave you the formula for conductivity. So before moving on to the formula for that conductivity, can anyone tell me the letter or the symbol, Greek symbol which we have used for conductivity? Do any of you remember? Very good. It is kappa, right? Very good. It is kappa. So what is the formula for kappa we have studied? It is G into G star, where G is the conductance and G star is the cell constant. Okay, clear for all of you? And also we have studied formula for resistance also. Can anyone give me the formula for resistance? What is the formula for resistance? What is the formula for resistance? Resistance R is equal to rho into L by A, right? So what is rho here? Rho is resistivity. Rho is resistivity and L is the length between the two electrodes and A is the area of cross section. Got it? So these are the three formulas which we have concentrated in the last session. And also we have discussed some problems related to these formulas. Okay. And also we have discussed some factors affecting the conductivity, right? Some 5 factors like size of the ion, nature of the electrolyte. So many more 5 topics we have studied under this. So today we are going to discuss about mainly the batteries and corrosion, and including to that we are going to discuss about the measurement of conductivity, Kohlraush law, and then at last we will move on to this main topic, introduction to batteries and primary batteries, secondary batteries and fuel cell, and at last corrosion. Okay. So the first main topic for today's session is measurement of conductivity. So we are about to complete this measurement of conductivity topic also in the last class, but we were able to discuss only the Wheatstone bridge part, right? So this part we have discussed in the last class. So already have discussed this now. We have 4 resistors R1, R2, R3, R4, and this instrument is called as Wheatstone bridge. Okay. And R2 is the conductivity cell, R1 is the variable resistance. Okay, and P is the detector. So whenever this particular detector shows no current, then R1 by R3 will be equal to R2 by R4. Then on rearranging this, the R2 value will come out to be R1 by R3 into R4. So using this particular formula, we can able to find out the conductivity cell R2 value. Got it? And from this only the kappa value we have discussed, which is G into G star. Voice is not coming. What about the others? Can others able to hear my voice? Gaurav, Sanika. Ashwin, Sakshi, can you able to hear my voice? Yes, yes. I think there is some problem with Yash network. Yash, just check your network. Go to the place where you can get a good network. So from this, kappa value was found out to be G star divided by R2. Okay, since G is equal to 1 by R2, we have got this substituted and we have got this formula. So I have completed the last class in this slide only. Okay, so just I am just recalling those part because it is the continuation, okay, of the topic which we are going to see in the next slide. So the next topic, the new topic for today is molar conductivity. So what is molar conductivity? The conductance of the volume B of solution containing 1 mole of electrolyte kept between two electrodes with area of cross section A and distance of unit length. Okay, the same thing. So molar conductivity is denoted by the letter lambda m. Okay, capital lambda m, and it is equal to kappa into V, where V is the volume and kappa is the conductivity. Okay, so and we know that volume is equal to number of moles divided by concentration. Number of moles divided by concentration. Actually, concentration is equal to number of moles by volume, right? So if you bring the concentration to the other side, in terms of molarity, we will get N by M. Okay, and for 1 mole, because the definition says that the conductance of the volume V of the solution containing 1 mole. So number of moles is equal to 1. Between two electrodes with area of cross section A and length is equal to 1. Okay, so it is 1 liter divided by M concentration, and 1 liter is equal to 1000 milliliter, right? So it is in place of 1 liter, we can substitute 1000 milliliter divided by M. So again, I'm saying this M is the concentration term. Okay, molarity concentration term. So we know that concentration is equal to number of moles by volume. So volume will be equal to number of moles by concentration. And here the concentration is denoted by the letter M. So in solutions lesson, we have discussed the concentrations, right? How many concentration terms we have discussed in solutions lesson? Do any of you remember that? How many concentration terms we have discussed? How many concentration terms we have discussed in solutions lesson? So it is around 6 to 7 concentration terms, right? So one among that is molarity. And now, if you substitute V is equal to 1000 divided by M in this particular equation, in this formula, we will get lambda M is equal to kappa into 1000 divided by M. Okay, got it? And this is the very, very important formula which we will be using for finding out the molar conductivity for the problems. Okay, and also we have unit. The unit of this molar conductivity is Siemens centimeter square per mole. Okay, Siemens centimeter square mole inverse. Got it? So students, can you able to understand the definition and the formula? If concentration is given to you in the question, then you have to use this formula. If straight away volume is given to us in the question, then we can go with the first formula itself. Okay? Yeah. Okay. Okay, my dear. So now we will go with one more point about this molar conductivity. So if you dilute, if we are diluting the solution, means if we are adding some water and decreasing the concentration, in that case, the molar conductivity increases. Molar conductivity increases. This point is very important. On dilution or with dilution, molar conductivity increases. Now, for strong electrolytes means strong acids, strong bases, strong acid base containing salts. Okay, so those substances are called as strong electrolytes. For strong electrolytes, we have one equation which relates lambda m and concentration, and it is this: lambda m is equal to lambda m naught minus root of c. Okay, And here lambda m naught is the molar conductivity at infinite dilution. Since we have diluted the solution, this lambda m naught denotes the infinite dilution molar conductivity. Okay, and we have a graph like this in which we are getting a straight line. So why we are getting a straight line here? Because this equation is of formula y is equal to mx plus c. Y is equal to mx plus c. Okay, so here m is the slope and the x-axis is root c. In x-axis we have root c and in y-axis we have lambda. Got it? And m is the slope. Okay, and the slope is negative. The slope is negative. And lambda m naught is the intercept. Intercept means the line which is intersecting the y-axis. Okay, and this point is called as intercept. So that is lambda m naught, which is called as molar conductivity at infinite dilution. And for strong electrolyte, we are getting a straight line because it is following the straight line equation. So the line is coming from left top to right bottom because of the negative slope. If the slope is negative, the line has to come from top to bottom like this, no? So we are getting a line like this, and this is a slope. This is a slope for this particular line. Got it? And that slope value is coming out to be a negative value. So this is for strong electrolyte. And for weak electrolytes, if you see, weak electrolyte means weak acid, acetic acid, and ammonium hydroxide, weak base, and weak acid base containing salts. So those are called as weak electrolytes. And for them, we have a law called Oswald law of dilution. For weak electrolytes, we have one law which is called as Oswald law of dilution. And according to this law of dilution, we are getting one formula which is alpha directly proportional to or inversely proportional to root C. Alpha directly proportional to 1 by root C or alpha which is inversely proportional to 1 by root C. Okay, what to see here? C is the concentration. What to see here? C is the concentration. Okay, so alpha is inversely proportional to the root of C. And you can see the graph, you can see the curve here in the graph for weak electrolyte. It is slowly decreasing, no? So as the concentration increases, the molar conductivity is decreasing. Molar conductivity is decreasing slowly. Got it? So alpha is the degree of dissociation and it is inversely proportional to the concentration. If the concentration is very less, then the degree of dissociation is low. So that is the meaning. Okay. So these are the informations which we are getting from molar conductivity. So the first thing you have to study is the definition for molar conductivity. Okay. So this is the first main point in which you have to concentrate. The second main point is the formula. Okay. And third main point is this line. Molar conductivity increases with dilution. Mostly for strong electrolyte, we are getting the straight line equation. Okay. Where lambda m naught is the molar conductivity at infinite dilution. And for weak electrolyte, alpha is inversely proportional to square root of C. And the very most important thing is this graph. Okay. So from the graph, they will ask you questions. Like they will ask you to find out the intercept and they will ask you to find out the line which is representing the strong electrolyte. So for strong electrolyte, we will observe a straight line. And for weak electrolyte, we will observe a curve like this. Okay. And which is the x-axis and which is the y-axis. So such kind of questions can be asked from the graph. So do all of you able to understand all the points which is given here on the slide regarding molar conductivity? Yes. Shall we move on to the next topic? So do any of you have any doubts? So Vaishnavi doesn't have any doubt. What about others? What about others? No. Okay. Okay, students. Okay, Sakshi. Okay, Sanika. Fine. Great. So next we will jump to equivalent conductivity. So far we have studied molar conductivity. Now we are going to study about equivalent conductivity. So again, we'll start from the definition for equivalent conductivity. So it is the conductance of the volume V of the solution containing one equivalent of electrolyte. So there we have studied for 1 mole of electrolyte and here one equivalent of electrolyte. That's all. The remaining things are same. So one equivalent of electrolyte kept between two electrodes with the area of cross section A and distance of unit length. So the definition for both the conductivity are same and there you have to use 1 mole and here one equivalent. That's all. Okay. So equivalent conductivity is denoted by the letter lambda EQ. Lambda EQ and it is equal to kappa into 1000 divided by N. So what is N here? Can anyone able to find out what is N? In the previous formula, we have got M. And I told you M is one of the concentration term and that concentration term is molarity. And here we are using N. So what is N? Can you able to find out what is N? Very good, Gaurav. Very good. N is the normality. N is called as normality. Normality is also one of the concentration term. Okay, but it will not be present there in solutions lesson or in your class 11 lessons. Okay, but it is also one of the concentration term. Got it? And the unit for this equivalent conductivity is Siemens centimeter square equivalent inverse. Okay, instead of mole inverse, we have to use equivalent inverse here. Got it? And as we know, normality is equal to molarity into N factor. So this particular formula you might have studied in your class 11. Okay, in class 11, we have got one lesson, no, some basics of chemistry, the first lesson, very first lesson of class 11. So in that lesson, we might have come across this formula. Normality is equal to molarity into N factor. Got it? So this is one of the old formula. So in place of this N, what we can do, we can substitute M into N factor. Okay. So on substituting the value, we will get a formula like this. Okay, where N has been substituted by M into N factor. Now, here if you listen carefully to the last equation which we have got, can you able to find out what is this? Kappa into 1000 divided by M. What is this? Kappa into 1000 divided by M. What is this? Just now we have studied. So this is the formula for, very good, Shastri. It is molar conductivity formula. Right? Very good, very good. Yes, yes, Mahik. It is molar conductivity formula. So instead of that whole term, kappa 1000 by M, we can substitute lambda M divided by N factor. Okay. So lambda M divided by N factor is nothing but lambda U. Okay. So here you have to concentrate on the definition and this for particular formula and the last formula. Okay. Among these two formula, the first formula is very, very important. Okay. Clear for all of you? So can you all able to understand molar conductivity and equivalent conductivity? Shall we solve one numerical problem? Are you all ready to solve that? So all of your doubts got clear now? No doubts in these two topics, right? Very good. So let's move on to the question. Yeah. So this is the question. What is the equivalent conductivity of cell containing a 0.1 normal solution of H2SO4 with cell constant 0.5 centimeter inverse and resistance 50 ohm? Also find its molar conductivity. So in this question, we are asked to find out equivalent conductivity and molar conductivity. So we have to find both. So to find both, we need the kappa value, right? Because we are provided with the normality value and we are provided with the cell constant value G star, okay? And we are provided with the resistance value, okay? But to solve this question, we need kappa. So what is kappa? kappa is equal to, conductivity is equal to G star divided by R, where G star is a cell constant and R is the resistance. We have the value for both of these terms and we can substitute that 0.5 divided by 50 ohm will give us 0.01 Siemens centimeter square. Okay, so now what we can do? We can take this kappa value and try to substitute in equivalent conductivity formula, molar conductivity formula, right? So can you able to find out the equivalent conductivity first of all? So the formula for equivalent conductivity is kappa into 1000 divided by N. We have kappa value, we have N value, everything is there in the hand now. So kappa value is 0.01 and into 1000 divided by normality value is 0.1 normal. So all of you do the calculation, do the calculation. So if you do the calculation, you will get 100 as the answer. Okay, 100 Siemens centimeter square per equivalent for equivalent conductivity. Now, for finding out the molar conductivity, you can straight away use this particular formula. Molar conductivity is equal to equivalent conductivity into N factor. From the last formula, which we have studied in the previous slide, you can rearrange this and get the molar conductivity value from this. So we have equivalent conductivity value in our hand, okay, and we have to find out the N factor. So how to find out the N factor and what is N factor? N factor means the number of H plus ion present in the compound. Okay, so what is the name of the compound which we have in this question? What is the compound we have? Did you find out the compound which is given in the question? What it is? H2SO4, right? Yeah, H2SO4. Sulfuric acid is the compound we have in the question. And it has, how many hydrogen ion it has? How many H plus ion we have in H2SO4? It is an acid. So acid will donate H plus ions. How many H plus ions we have in H2SO4? Very good. So what is the N factor? N factor is equal to 2. Very good, students. N factor is equal to 2. So that straight away substitute the value of 2 here in the lambda N formula. So lambda M is equal to lambda EQ, so which is 100 into N factor, which is 2, and 100 into 2 will give 200 Siemens centimeter square per mole. So that's all. Very easy, right? So do any of you feel difficult in solving this question? Is it very easy or you feel it difficult? It's very easy, no? So what you have to do, first of all, you have to understand the terms given in the, yeah, it is very easy. Good friend. So you have to, yeah, great. So you have to understand the terms or the values which are given. And you should be able to find out the terminology for that given value. Okay, suppose if it is 0.1 N solution of the means it is a normality. If we are seeing N there, it is normality. Normality means it is a concentration term. And we are provided with cell constant. So cell constant means you should think what is cell constant and it is denoted by G star. So like that you have to think and recollect all the things you have studied. And first of all, you have to write all the given values. Then go for the term which has been asked, equivalent conductivity and molar conductivity. After seeing these two, okay, what you have to do? You have to think of the formula which we have to apply to solve this question. Okay, then after recollecting that particular formula, you have to think what are the terms required to get that particular term. Okay, so we need a kappa and we need normality. Normality is given, kappa is not given. So how to get kappa? So we can get kappa from many ways. We have already studied one more formula, no? Kappa is equal to G into G star. So like this, we do have many formulas to find out a single term. And you have to select which formula has to be used here in this particular question. So how do you find out that? By seeing the given values. So G star and R is given. So only this particular formula will work out to get the kappa value. So just divide and then do all the calculation, then get the value. Clear? Good. So daily you have to solve the problems like this. If you solve it, it is going to be very easy. Got it? So I hope the measurement of conductivity and molar conductivity, equivalent conductivity topics are very clear to all of you. Am I right? Shall I go with the next new topic? Do you have any doubts from this? No. Okay, students. So let's move on to Kohlraush Law. Yeah. Okay, Vaishnavi. Good. Okay. Okay. Kohlraush Law. Kohlraush is the name of the scientist, and we are going to study his law. So it is also called as Kohlraush Law of Independent Migration of Ions. So migration means movement from one place to another place. So who is going to move? Ions are going to move. So it is independent migration of ions. So each ion is going to move separately. Okay. So let me take a beaker, and in the beaker I have a solution, and that solution, electrolytic solution, has cation and anion present inside it. Okay. So I have 3 cation and 2 anion, right? So there will be some force of attractions between these ions. Okay. And I have one more beaker in which cations and anions are present, and there are force of attraction here also. In the first case, if you see, the distance between the 2 ions, they are very less. But in the second case, the distance between 2 cation and the distance between 1 anion and 1 cation is little bit bigger. Okay, it is higher than the first case. So now coming to the Kohlrausch law, it is the limiting molar conductivity of an electrolyte can be represented as the sum of the individual contribution of the anion and cation of the electrolyte. Sum of the individual contribution of the anion and cation of the electrolyte. NaCl is the electrolyte, and the contribution of cation is Na plus. Conductivity means lambda m naught. Okay. And the contribution of anion is Cl minus contribution. So we have to sum up the contribution of both the ions. If we sum up those two, we will get the limiting molar conductivity, which is denoted by the letter lambda m naught. So lambda m naught, limiting molar conductivity, lambda m naught, limiting molar conductivity is equal to the sum of the individual constant contribution of the anion and cation. So mathematically, it is denoted by lambda m naught equal to small lambda. This is capital lambda, you can say this is small lambda, okay? So just to make the differentiation. So cation means small ions, no? So this is the total. So I have used capital lambda and this is small lambda. So lambda m naught of cation and lambda m naught of anion. So summing up the contribution of these two ions will give the value for limiting molar conductivity. Okay, now for this particular example, the electrolyte is the NaCl. So the cation is Na plus and the anion is Cl minus. So their contribution will give the limiting molar conductivity of the electrolyte. Okay, very easy now. You have to study the definition, then this particular formula, that's all. Okay, so shall we do one problem? Shall we do one problem and shall we find out the molar conductivity for the compounds? Yes. So here is the question. Given that lambda m naught of Mg2 plus, Cl minus, OH minus, and K plus are 106, 76.3, 199.1, and 73.5 Siemens centimeter square per mole. Okay. Calculate the molar conductivities of MgCl2 and KOH at infinite dilution. So, how to solve this? How to approach? So, first of all, take MgCl2 and dissociate it. How will you dissociate MgCl2? MgCl2 can be dissociated like Mg2 plus and 2Cl minus. Okay, Mg2 plus and 2Cl minus. So I have dissociated. Okay, now we have to substitute the lambda m naught values of Mg2 plus and Cl minus. And since we have 2Cl minus here, I have to multiply the given value by 2. Okay, lambda m naught MgCl2 is equal to Mg2 plus value into 2 into Cl minus value. So all of you do the calculation. What is Mg2 plus value? It is 106. So substitute 106 in place of Mg2 plus and 2 into 76.3 plus 2 into 76.3. So multiply these two and add with 106 and give me the answer in the chat box. Very good, students. It is 258.6. Sakshi, Sanika, very good. I hope you guys are having the notebook with you and solving the problems. I want all of you to have that habit. Okay. I can able to see some guys are not keeping the notebook with you. So don't be like that. As I have already told you in the first class, try to maintain a separate note for chemistry from beginning onwards. Okay. So maintain a proper notes and have a neat notes. So that only will help you in the end. Okay. So for all the revision purpose, that only will help you. So at the last time, you cannot go through all the lessons like this. Okay. So then they will rush up. So you may not able to concentrate more on a particular topic. So from the beginning onwards, if you are maintaining a proper notes, so that will help you. Got it? So as Sakshi and Sanika have said, it is 258.6. Sakshi have got the value for the second KOH also. Both of them have got the answer for KOH also. Very good, students. Mahek also got 272.6. Okay, let's check. Okay. So how to dissociate KOH? It is K plus and OH minus. So K plus is 73.5 and OH minus is 199.1. So answer is 272.6. Very easy, no? That's a kind of very easy question. So many students, what do they do, you know? So they will think like electrochemistry is a very toughest lesson and very difficult lesson for them. It is not the case actually. Okay, this is one of the very easiest lesson. If you understand all the problems and if you try to understand all the formulas and if you practice how to apply the formulas to the question, then it is the very easiest part in which you can score marks. It is one of the physical chemistry lesson only. If we say take some time for doing multiplication division in some parts, not in all the cases, okay? So otherwise it is going to be a addition subtraction like this. Got it? So students, what do? They don't understand first of all. They don't understand. They don't know which formula has to be applied to. They don't know what is molar conductivity. Then how will they apply? So you all should not be like this. And I hope you guys will not do the same mistake. Okay? So try to understand and study each and everything. So shall I move on to the next slide, students? Any doubt from this part for anyone? No doubt. Okay. So Kohlraush Law of independent Ritija mode. Okay, my dear. Ritija, good. So Kohlraush Law of independent migration of ions. Now we are going to study some more informations related to this topic. So let me take a weak electrolyte first. For a weak electrolyte, molar conductivity depends on the degree of dissociation of the electrolyte. I already told you, degree of dissociation is denoted by the letter alpha. So for weak electrolyte, it depends on the alpha value. So what is alpha? Alpha is equal to lambda m divided by lambda m naught, which is the very important formula. Molar conductivity divided by limiting molar conductivity will give you alpha. Okay. Suppose Weak electrolyte means I already told you, weak acid, weak base. Those are the examples of weak electrolyte. So can you give me an example for weak acid? Very common example which we use for weak acid. Can anyone tell me? So in class 11, you might have studied the list for weak acid, weak base, strong acid, strong base, and equilibrium lesson, no? Can you able to recollect that? Can anyone tell me one example for weak electrolyte, weak acid? Very common example for weak acid. None of you remember? Not even a single student remember class 11. What is the example for weak acid, maybe students? We can take acetic acid as an example, no? Acetic acid. At least tell me the formula for acetic acid. What is the formula for acetic acid? What is the formula for acetic acid? Oh my God. See, 12th standard is the 11th is the base to 12th. We should not forget the class 11 concepts. Okay. So the formula for acetic acid is CH3COOH. Yeah, it is CH3COOH actually. Very good. And if you try to dissociate that acetic acid, it will get dissociated like this. No? CH3COO minus and H plus. Since it is a weak acid, the dissociated ions will be in equilibrium with the initial compound. Okay. So weak acid means only partial dissociation of ions will be there and they will come back again and they will go back to the initial reactant again. Both of them will be in equilibrium in case of weak acid. If you are going for strong electrolyte, then equilibrium will not exist between them. If one compound gets dissociated, that's all. Again, they cannot come back and go back to the original position. Okay, so this is the difference between weak electrolyte and strong electrolyte. Now, for this particular relation, the acid dissociation constant, which is represented as Ka, so that is equal to C alpha squared divided by 1 minus alpha. So these formulas, these parts we have discussed in equilibrium lesson of class 11. Okay, where C is the concentration, alpha is the degree of dissociation. Okay, and we know that alpha is equal to lambda m divided by lambda m naught. So in place of alpha, substitute lambda m by lambda m naught. So you will arrive at this particular formula, and after cancelling out the many this terms lambda m naught term will get cancelled, and we have C into lambda m square divided by lambda m naught into lambda m naught minus lambda m. So we are getting this last relation by substituting the value of alpha here. Okay, so all the three formulas are very, very important. So the first formula is already, I have told you, it is very important. In Ka formula is also very important. And Ka have one more relation which we are getting from the first two. Okay, from the first two only we are getting the last relation. So that is also very important. Got it? Clear? So let's do one question, okay, based on this. If the limiting, students, do you have any doubts from this? All of you got clear now from the last topic, which I have told you from from these two formulas. None of you have any doubts, right? We can go on to the problems now. Did you all take down the formulas in your notebook? Yes or no? Okay, we'll go with one question. Fine. If the limiting molar conductivity of BaH to BaCl, the NH4Cl are 523, 280, 129, C1 centimeters per mole, calculate the limiting molar conductivities of NH4OH. So this type of questions are again very easy. We are provided with three compounds value and we are asked to find out for one compound. So what we have to do, try to get, so write all the given values, limiting molar conductivities of the three values first. And from here, NH4OH will be dissociated into NH4 plus and OH minus. This is the desired equation for which we have to find out the limiting molar conductivity. So how to get this equation from the given three compounds? So in the desired equation, we have NH4 plus and OH minus. So check for OH minus. So we have OH minus and BaOH twice. So BaOH twice has to be dissociated like this, and BaCl2 will dissociate like this, and NH4Cl will get dissociated like this. Now, if you do equation 1 plus 2 and multiply that with equation 3, and if you subtract that with equation 2 and dividing by 2, you will get the value for the NH4OH. Okay, you get the value for NH4OH. Clear? So you can also go like this. BaOH twice plus NH4Cl gives BaCl2 plus NH4OH. Okay. So here we have OH minus ion. Here we have an acid, ammonium chloride. Okay. So they will react with each other and they will form ammonium hydroxide and barium chloride. And you can substitute the values. Barium hydroxide value is 523.28 plus NH4Cl value is 129.8, which is equal to BaCl2 value is 280. And the NH4OH we have to find out. So you can keep X in one side and you can add those two. You can add 523.28 plus 280. Okay, and you can subtract that from this. So you will get the value for the given equation, desired equation. You can go with this method also. Okay, so the final answer will come out to be 251.44 Siemens centimeter square per mole. Got it? Is it clear for all of you? Yeah. So let me summarize. Let me summarize the today's lesson. So today's topic which we have studied. So we have studied molar conductivity, which is lambda m is equal to kappa into 1000 by m, and equivalent conductivity, which is kappa into 1000 divided by n, and Kohlraush law, which is the limiting molar conductivity of an electrolyte as a sum of the individual contribution of the anion and the cation. And for weak electrolytes, alpha is equal to lambda m divided by lambda m naught. Okay, so these are the four important formulas which you have to keep in mind. Clear? So with this, I'm going to wrap it up the today's session. So do any of you have any doubts from these topics? So students, do any of you have any doubts from today's lesson? No? Okay. So meet you all with batteries and corrosion topic in next session. Okay? Thank you, students. Thank you so much for attending the today's lecture. Take care. Bye.